Well, we've taken a quick superficial summary of the strange quandary that the quantum physicists are in, that they're confronted with non-local, I can't even call it reality. They're at the boundaries of reality. If all our common sense notions about the universe were correct, then science would have solved the secrets of the universe thousands of years ago. Part of the problems is we're constantly confronted with things that aren't in the category that you and I would consider common sense. One of the things that we're going to discover as we get into this session is that higher dimensions of geometries may be the ultimate source of insight in terms of our conceptions of reality about our universe. It's kind of interesting that in about the 2nd century, about 150, astronomer Ptolemy of Alexandria is probably going to be famous because he's going to go down in history as opposing the two great ideas in science that turned out to be true. He was the one that said the sun was at the center of our solar he opposed the idea that the sun was at the center of the universe. He's the one that thought the sun went around the earth. That was his one great contribution. The other one is he also proved conclusively that there couldn't be any such thing as a fourth dimension. It's kind of interesting they were talking about this in the 2nd century A.D. But his logic was very simple. If you have length that's perpendicular to width, that's perpendicular to height, you can't have another dimension that's perpendicular to those three. And that was his way he proved there was no such thing as a fourth dimension. And it's going to turn out to be that he's going to go down in history as being wrong on both of his major tenets. Now, to go further in our discussion, I need to introduce to you two friends. But before I introduce my two friends, I want to warn you to be compassionate, because my two friends that I want to introduce suffer from a very serious handicap. They only live in 2 dimensions. And I'd like to introduce you to Mr. and Mrs. Flat. I'm going to take Mr. and Mrs. Flat. Now, Mr. and Mrs. Flat, as I say, have this tragic malady. They only live in 2 dimensions. You say, what am I getting at here? It turns out that the only people that can deal with more than 3 dimensions are mathematicians that are specially trained and small children. You and I have grown up in a 3-dimensional world. And it becomes very quickly evident, if you start getting into hyperspaces, that you and I, unless we have very peculiar special training, can't visualize problems that occur in more than 3 dimensions. But we can get some easy, valuable insights by going down in dimensionality. And believe it or not, this was first proposed in a novel called Flatland that was written by Edwin Abbott in 1884. He was a clergyman that happened to write a novel, and it's famous for this very reason, because he dealt with a world called Flatland. It was populated entirely by 2-dimensional beings, and he had some fun with that. But it turns out to be kind of a useful little thing, because I like to talk about Mr. and Mrs. Flat. They live in only 2 dimensions. They have no thickness. They're in a 2-dimensional world, and you're obviously imaginary. If Mr. Flat looks at Mrs. Flat, what does he see? A line, exactly. Now, if Mr. Flat goes around Mrs. Flat, he can integrate what he sees to create a 2-dimensional conception of Mrs. Flat. You and I do the same thing. When I look at you, I see a 2-dimensional image. I see it one in each eye, and so I can integrate 2 of those to get a 3-dimensional conception of what you look like. But what I actually see is always 1 dimension less than the domain I'm in. He does the same thing. He's in a 2-dimensional world. He sees a 1-dimensional image. You with me? That figures. Now, if I come along as a 3-dimensional being, I can start to do some kind of interesting things. First of all, I can take Mrs. Flat out of there. And if I lift Mrs. Flat up out of the 2-dimensional world, all he knows, she's gone. He has no conception of where she is, because she's no longer within his 2-dimensional world. Let's put her back. Now, when she returns, the analogy would be, if we're in this room, and we have a floor and a ceiling, and 4 walls, imagine all the doors locked and windows locked. and imagine a three-dimensional being emerging right in the middle of the room without passing through the floor, ceiling, or four walls. You and I have no capacity to visualize that. And yet it happened in the upper room that Sunday evening. More than once. Right? What does that prove? Was it a spirit? Was it? No. He says, spirit does not have flesh and bone. He's tangible. He had a real, whatever that means, real body. And yet, he could pass through three-dimensional spaces. What does that tell us? He had more than three dimensions. He was in a hyperspace. Something else that's kind of interesting, let's get back to Mr. and Mrs. Flat. Let's assume I come along as a three-dimensional being. I can get closer to Mr. Flat. I can hover over him, and I can put my finger, say, 1/1,000,000th of an inch above where he is. You with me? I can get close, I can be more intimate with Mr. Flat than Mrs. Flat ever could be. Furthermore, I can do the same thing with Mrs. Flat no matter where they are in their world. You can spread Mr. and Mrs. Flat far apart. But as a three-dimensional being, I can put a finger 1/1,000,000th of an inch away from either one of those. So as we begin to play with this, we begin to realize all God has to be is some number of dimensions more than we. And all these mysteries go away. How can God be intimate with all of us when we're here and our relatives are in New York or California or whatever? And yet God can be intimate with all of them at once. It means he has enormous bandwidth. It also means he has more than three dimensions. And if you give a Bible study at a place like Caltech, they'll quickly conclude that he has to have at least 11 dimensions for reasons I won't bore you with. I get around the whole problem because it turns out that mathematicians talk about a Hilbert space. A Hilbert space is a hyperspace of an infinite number of dimensions. I have no proof of this. I just instinctively suspect that if I had to estimate the dimensions of God, it's going to be more than 11. It's going to be infinity. But we begin to realize the enormous conceptual power of just adding one dimension in this situation here. Now, what we're going to discover as we explore a little further tonight, the laws of nature become simpler as you go up in dimensions. They become more elegant in higher dimensions. Einstein's theory of relativity that made him so famous was simply to recognize that you and I live in a four-dimensional world. Length, width, height, and time. 4 dimensions. He went to his grave frustrated that he couldn't integrate it all with gravity. And all he had to do was go up one more dimension to 5 dimensions, as we'll see in a minute. But enough of this for now. Thank you. What starts to emerge also there's so many parallel developments here, but the one I want to touch on briefly is what's called field theory. In the 19th century, it started with a British scientist by the name of Michael Faraday. Started the development of conceptions of fields. In the 1860s, James Clerk Maxwell again developed his field equations for electricity and magnetism. And of course, as you know, in 1915, Einstein developed his field equations for gravity. And he was frustrated because they were not unifiable with Maxwell's electromagnetic equations in 4 dimensions. He was troubled by the fact he understood we had an integrated set of 8 equations, the Maxwell equations, and we also understood gravity. They explained each, but they always had this feeling they somehow, to really unify physics, we should be able to unify them both, and he was frustrated. Now, part of the problem is that you and I are familiar with a geometry that's known as after Euclid. We call it Euclidean geometry, and that basically argues that space is 3-dimensional. And Euclid's original writings, called Elements, was revered for 2,300 years. So you and I tend to think, scheme, conceive, plan in Euclidean geometry. I might mention, by the way, the 3-dimensional Euclidean geometry is the only dimension in which knots stay knotted. I don't know what you're going to do with that piece of information, but I thought I'd throw it in. Give me the triangles, if you would. You know, all of us from school learned that a triangle has 180 degrees, right? You add up the angles of triangles, 180 degrees. If you have a 90, 30, 60 triangle, it adds up to 180 degrees. If you have a 45, 45, 90, you have 180 degrees. How many knew that? Good. Okay. Well, now you go out here and you get your transit and you measure angles of a very, very large triangle. And let's assume it adds up to something more than 180 degrees. Suppose you add up the angles you've measured, comes out to, say, 210 degrees. Would you be uncomfortable? You'd probably go back and check it again. Suppose, let me give you another triangle. Suppose you do this, move it up a little bit. Suppose I have a triangle that has 90 degrees in each of its three corners. Would you be uncomfortable? No. All it means is you are on a curved space. Try to give me the next. Most of us have learned Euclidean geometry, which assumes three dimensions. If you are on the surface of the Earth, if you take navigation for either aircraft or sailing, what have you, you learn spherical trigonometry. In spherical trig, you can have three angles adding up to, you name it. In other words, there's nothing. The point is, to the extent that those angles add up to more than 180 degrees on a triangle, it's telling you that you are in curved space. And that's exactly what Einstein began to recognize as he wrestled with the problems of light and time and the three dimensions that we all are familiar with. And that's how he realized that we were in a four-dimensional space, not a three-dimensional space, and that led to his theory of relativity. Now, you can turn that off for now. This in June 10th of 1854, one of the most important public lectures was given in the history of mathematics, where George Bernhard Riemann developed the Riemann geometry. He was born in 1826 in Hanover, Germany. He was the son of a poor Lutheran pastor. He studied the Bible intensely, but he's also very gifted in mathematics. Studied under Carl Friedrich Gauss. And Gauss has been acclaimed the prince of mathematicians, if you're familiar with that background. And so he was the first to lay the foundation of geometries in higher dimensional space. And he also recognized that force was a consequence of geometry. We talked a little bit about that in the first session, the first package called Beyond Time and Space. I won't go through all that again here. But I want to talk a little bit about these spaces. Most of us in school had exposure to what's called the theorem of Pythagoras, which is, again, a relationship of triangles. Can you give me the Pythagorean theorem? Right. Basically, Pythagoras recognized that if you have a right triangle and you take two of the sides and square them and add them together, you end up with the square of the hypotenuse. The hypotenuse being the side that's opposite the 90-degree angle. In other words, 3 squared plus 4 squared is equal to 5 squared. In other words, 9 plus 16 is 25. So if you know any two sides of a right triangle, you can find the third one by the Pythagorean theorem. So I think all of you have been one way of expressing it is a squared plus b squared equals c squared, where those are the lengths of the three sides. Now, that's in how many dimensions? 2 dimensions. Give me the next slide. You can do the same thing in 3 dimensions. Imagine this room, which has a length, a width, and a height, and let's imagine we wanted to find out what the diagonal in this room was, from that corner up to this corner. Well, you can do the same thing. You can take the first side square it, the second side square it, the third side square it, sum them, and you get the hypotenuse. You notice the difference. Before we had a squared plus b squared equals c squared. Now we just add another term. We've added another dimension. How would you find the hypotenuse of a 4-dimensional triangle? If I asked you to draw one, you'd have a great deal of difficulty. Unless you had some very special skills, you probably are not able to draw a 4-dimensional sketch called a hypercube or a hypercube. Salvador Dali used it in one of his paintings of the Crucifixion of Christ. But the point is, most of us wouldn't recognize or understand what we're not used to dealing with hyperspaces. But we would know how to find the hypotenuse, because We can just, instead of taking x squared plus y squared plus z squared, we can say x squared plus y squared plus z, and just add another term, which for here I've just called t for no good reason. And if I add those squares, I get the length hypotenuse. Instinctively, by extension, we recognize the symmetry, we recognize the beauty, the poetry of the mathematics that would give us the correct answer. Now, suppose I wanted to find the hypotenuse in an n-dimensional space. You couldn't possibly visualize it, but you could calculate it if I gave you the lengths. Okay, are we together so far? Okay. Now, it's kind of interesting, before I leave this, the main point is, as we go up in higher dimensions, we're going to discover that the various forces that we're struggling with in subatomic physics start to become clear. And it's pretty exciting. Now, Einstein took us from 3 dimensions to 4 dimensions and recognized that time was the 4th dimension. And we talked before, but I want to remind you of something we did in our earlier session in Beyond Time and Space to talk about time as this dimension. There's a thing we call a Feynman diagram. Take that down and give me the next. Feynman at Caltech developed these diagrams. The convention is that time is the vertical and space is the horizontal. So as time passes, you move up the chart, if you will. On the left, we see the representation of an electron that collides with a photon. And, the E with a minus is an electron. The E with a plus is a positron. And when we encounter those in a cloud chamber or wherever, they mutually annihilate each other and give off a gamma ray. Okay? And likewise, a gamma ray can collide with, can give rise to both of them. Now, the point is that the diagram on the right is identical, physically and mathematically, the diagram on the left. They're actually both the same. The reason they're both the same, it happens that the photons are their own antiparticle. But the main point I want you to notice, do you see the middle part of that diagram? On the left diagram, it's a positron. A positron and electron are said to annihilate each other. They're equal and opposite. They're equal in mass, opposite in sign. When they collide, they annihilate each other. It turns out to be mathematically consistent to view that positron as an electron in a reversal of time. That electron can go backwards in time. We see it as a positron. Now that happens to be rather startling if you're trying to study the nature of time, because scientists wrestle with the idea, can time go backward? It turns out, it comes as a surprise to many, that even adopting the most advanced mathematics that we have, you cannot prove that you cannot go backward in time. That leads to some logical contradictions, don't misunderstand me. But if you had enough energy, now the problem is it takes more energy than we would have, that we could even imagine in the next few centuries, so it's not a practical result. But it's interesting mathematically that the reversal of time is at least conceptually possible. That comes as a shock to many. And of course, it's argued about by various physicists. Now, I want to touch on this a little bit. This leads to the whole concept of time travel, and that's a very popular subject in literature. Most of us may have seen H.G. Wells' The Time Machine. It's one of the classics written in this idea. We saw a movie some time ago called Somewhere in Time, where the guy goes back in time to meet his lover. And recently, Back to the Future was an example of this, and Terminator, the series, was the same kind of concept of time travel. One of the things that time travel leads to, of course, is logical contradictions. The idea of going back in time and killing your grandfather. And how can you exist? You get in those problems. You also end up with events that have no beginning. And as most of you probably have encountered examples of literature called time warps, where this kind of an idea is used as a literary device for entertainment. But I came across what has to be the ultimate time warp story by Robert Heinlein. If you're a science fiction buff, you know the name Robert Heinlein, a very imaginative writer. But he wrote a story in which a baby girl is mysteriously dropped off at an orphanage in Cleveland in 1945. Follow this carefully. Jane grows up lonely and dejected, not knowing who her parents are, until one day in 1963, she is strangely attracted to a drifter. She falls in love with him, And just when things are finally looking up for Jane, a series of disasters strike. First, she becomes pregnant by the drifter, who then disappears. Second, during her complicated delivery, the doctors are shocked to discover that Jane has 2 sets of organs, and to save her life, they are forced to surgically convert her to a him. Finally, a mysterious stranger kidnaps her baby from the delivery room. Reeling from these disasters, rejected by society and scorned by fate, he becomes a drunkard and a drifter. Not only has Jane lost her parents and her lover, but he has lost his only child as well. Years later, in 1970, he stumbles into a lonely bar called Pop's Place and spills out his pathetic story to an elderly bartender. The sympathetic bartender offers the drifter a chance to avenge the stranger who left her pregnant and abandoned on the condition that he join the Time Travelers Corps. Both of them enter a time machine, and the bartender drops off the drifter in 1963. The drifter is strangely attracted to a young orphan woman who subsequently becomes pregnant. The bartender then goes forward 9 months, kidnaps the baby girl from the hospital, and drops off the baby in an orphanage back in 1945. Then the drifter eventually gets his life together, becomes a respected and elderly member of the Time Travelers Corps, and then disguises himself as a bartender and has the most difficult mission, a date with destiny, meeting a certain drifter at Pop's Place in 1970. You follow all that? The question is, who is Jane's mother, father, grandfather, grandmother, son, daughter, granddaughter, and grandson? The girl, the drifter, the bartender, of course, are all the same person. Now, this, of course, is a paradox of very twisted genealogy, and she's an entire family tree unto herself. And, of course, it's all done tongue-in-cheek. It's Robert Heinlein's creative way of probably convoluting the most absurd application of these time warp ideas. But it's kind of interesting what Albert Einstein said about all of this. He says, people like us who believe in physics know that the distinction between the past, the present, and the future is only a stubbornly persistent illusion. It fascinates me as we joke about this literary-wise, but it's interesting that when Moses was before the burning bush and God called him for his mission, he says, who shall I say sent me? And God's name, his name is the Ihyach Asher Ihyach, the I am that I am. He who was, who is, and always will be. One that transcends time altogether. Getting back to this, we now discover our universe is a hypersphere, a sphere in 4 dimensions. But it's interesting that Einstein went to his grave not being able to carry the unification any further. And that brings, in April 1919, there was a letter to Dr. Einstein from Theodor Kaluza, University of Königsberg in Germany, now called Kaliningrad in USSR, or in Russia. The letter theorized about a 5-dimensional theory of gravity in which light, this is 1919, in which light could be viewed as vibrations in the 5th dimension, curled up within the Planck length that is 100 billion times smaller than a proton. It turns out in 1926, Oscar Klein made some improvements and calculated the 5th dimension that was curled at 10 to the minus 33 centimeters. That's the Planck length. And that is too small to ever be empirically verified because it's smaller than the Planck length. Now, the required energy to test that would be 10 to the 19th billion electron volts. And that's even conceivable as the energy required to test that. So the idea became dormant after 1930. But it's interesting that along comes quantum mechanics. Along comes Schrödinger and his cat. Along comes Werner Heisenberg and his uncertainty principle and all of that business. And the two-slit dilemmas and so forth. Then this concept that light may not be waves or particles, they may be vibrations in a higher dimension, starts to take hold. Now this leads us to another thing. There's another piece of math. All these end up having to be accompanied with mathematics, and I'm trying to avoid that as much as possible, but let me give you just a quick insight. Another way to describe space, rather than algebra or Feynman diagrams, another way to describe it is with what's called a metric tensor. Give me the metric tensor, if you would. One way to describe a field in curved space is with these 16 numbers, but it turns out there are actually 10 of those numbers describe 4 dimensions. It turns out that if there were real numbers in there, 6 of them are symmetrical and therefore redundant. So you got 4 by 4 here for a 4-dimensional space, but it'll turn out that in this kind of reckoning, 6 of them are symmetrical. So you've actually got 10 numbers that describe a 4-dimensional space, and it would be possible to describe any problem we have in 4-dimensional space in terms of a metric tensor. And now, if you give me the next slide, it turns out, and I haven't tried to get too mathematical here, but if you add a 5th dimension, you add additional numbers, it turns out that in this reckoning, light can be described in the 5th dimension. But let's move on. There's the following succeeding Maxwell is a guy by the name of C.N. Yang, and he had a student by the name of R.L. Mills. They generalized Maxwell's equations. Maxwell's equations are 8 clumsy, very important, but very clumsy, awkward equations. They discovered that Maxwell's 8 equations, when rendered in 4 dimensions, come out as one simple, elegant equation in 4 dimensions, and that put them on the track. And so it turns out that in the 1970s, Yang and Mills, his student, discovered that all nuclear matter could be unlocked by the Yang-Mills field. And they called this the Standard Model. The strong force, the quarks, the 3 colors and 6 flavors and anti-quarks and all that, there's 36 of those, are held together with packets of energy called gluons, etc. And so we have the strong force, we have the weak force. Remember those 4 forces. The weak force governs the properties of the leptons, such as the electron, the muon, the tau mason, the neutrino partners. And also the electromagnetic force of Maxwell. All matter consists of quarks and leptons which interact by exchanging different kinds of quanta. And give me the next slide. It turns out, another way, rather than put all those numbers down, if I take the first 4-dimensional space and call that Einstein with his theory of relativity, if I add the Maxwell equations by going up 1 dimension, they become one single elegant equation within that structure. Give me the next one. Yang-Mills, I add another dimension, and all of the 4 forces come together. Now, as we get this far, we're talking what's called within the trade the Standard Model. It turns out it still has some inconsistencies and some problems, especially with respect to gravity. It was still incomplete. Now that leads me to the final frontier in physics. Give me the next slide. No, just there you go. Anyway, as you build up the mathematics, adding dimensions. Each time you add a dimension, more and more of it come together. And that leads you then to what's called today, the physicists are grasping at what some people call a theory of everything. What they're trying to do is find the mathematics and the conceptions that totally reconcile all that we know, both at the cosmic level, gravity and planets and all that, all the way down to the subatomic level. And that's a theory of everything, and the primary candidate that has surfaced, that everybody is very optimistic about but is yet to be fully developed, is a theory called superstrings. And it turns out that the quantum chromodynamics and the general relativity look like they can be reconciled with superstrings. Now, what a string here is a term, you can turn that off if you want. A string here is a term that you and I have a hard time probably visualizing. We're talking about one-dimensional strings instead of a point. When you think of in our geometry, we always think of a point as the small point. Instead of a point, they speak of strings, and these strings stretch across the universe, but they're smaller than a single atom. Gravity waves, they regard as ripples in the fabric of space-time. They're associated with a particle called a graviton with 0 mass and a spin of 2. They have loops of tunnels through space, but they're down to 10 to the minus 33 centimeters, so you can't see them in the typical way. Each point of space at each moment of time is actually a tiny but complex, curled up, six-dimensional world. And one way to visualize this, perhaps, is if you were looking at an aerial photograph of a garden hose. See, in the aerial photograph, your view of it would be two-dimensional, but it actually can be more than that itself. Now, the reason I'm getting into this is because 500 years ago, those Hebrew Kabbalists that we talked about, Maimonides and Nachmanides, they studied the text of Genesis chapter 1 very carefully. And they were convinced that Genesis chapter 1 in the Hebrew teaches that God established the universe in 10 dimensions. From Genesis 1, it says, "And God said," 10 times. And they, for their own Kabbalistic reasons, believe that implies that originally there's 10 dimensions. 4 of them are knowable. 6 of them were contracted into submicroscopic dimensions during the first 6 days of Genesis. I can't resist showing you Ephesians chapter 3. Paul says in Ephesians chapter 3, starting about verse 17, that Christ may dwell in your hearts by faith, that ye, being rooted and grounded in love, get verse 18, may be able to comprehend with all the saints what is the breadth and length and depth and height, and to know the love of Christ which passes knowledge. Well, let's go back to that again. Let's see. It says the breadth, the length, the depth, and height. How many are there? 4. That's kind of interesting. Might be just a figure of speech, some would say so. And yet it's very interesting that Maimonides and Nachmanides, not from the New Testament, from their study of the Torah, are convinced that God had originally created the universe in 10 dimensions. 4 of them are knowable, as in their terms. 6 are unknowable. Now, it turns out that this whole theory of superstrings, it turns out the current theory in physics is that we live in a universe that is a 10-dimensional universe with vibrating strings. They call them heterotic strings. Clockwise vibrations that live in a 10-dimensional space, counterclock live in a 26-dimensional space. They are 100 billion times smaller than a proton. Thus, a particle is not a point at all, but a mode of a vibrating string. Matter is nothing but harmonies or resonances created by this vibrating string. It fascinates me as I read all this to also notice that the key to life is also string-like in terms of the DNA being the double helix. It seems to be an interesting architectural concept. So anyway, what this all adds up to be, the present view is that the symmetries of the subatomic realm are but remnants of a symmetry of a higher dimensional space. Symmetry is a big preoccupation among the particle physicists. They notice that all particles have an antiparticle, which causes them, these are secular scientists, to conclude that originally the universe was made out of nothing. That's why they always balance. That's why there's always a negative for a positive, etc., because it was created out of nothing. Well, that's exactly what Moses wrote in Genesis chapter 1, verse 1. Bereshit bara Elohim. In the beginning, God created. Bara, the Hebrew word, means to create out of nothing. There are 3 words, but bara means to create out of nothing. There's a very important Indian mathematician, Srinivasa Ramanujan, and the Ramanujan function deals with is a key part of the mathematics. It turns out that only in 10 and 26 dimensions are they self-consistent. And so I was fascinated because the physicists now are all tangled up in 10-dimensional space for obvious reasons, because the whole concept of quantum physics led them to a dead end, this concept of the boundaries of reality. So that the way you get out of that paradox is to recognize that we're dealing with more dimensions, just as Einstein went to 4 and stopped there, and Kluze-Klein went to 1 more and discovered that somehow he solved light with gravity. On it goes. Now, I couldn't help but notice something else that's kind of interesting. If you study the Psalms, the psalmist always praises God on what? On an instrument of how many strings? 10 strings. Does that have anything to do with anything? I don't know. I'll leave that to you. I think it's kind of interesting. As you read the scientific philosophers, the physicists, they have this view that we not only will we understand these hyperspaces, they believe that may be they theorize that may be the ultimate destiny of man. Because as our own universe collapses or has problems, they can visualize a day, obviously way in the future, in which intelligent life may have to escape ultimate collapse by fleeing into hyperspace. And as you read some of that, I couldn't help but figure they're absolutely right. You and I are destined, if you're in Jesus Christ, to undertake an interesting journey through hyperspace. But let me back up and summarize. The quantum physicists live in a self-contradicting world. Nothing is real. You cannot say anything about that, what things are doing when you're not looking at them. Nothing is real unless it's observed. That's experimentally verified over and over again. They've dropped causality. Things are not causal, they're not determinate, they're probabilistic. Reality is non-local. Reality, the particles throughout the universe are connected. The grand unification in physics, that is, that charge is always net to zero, indicates that the universe possesses no conserved quantities that do not net to zero, and thus that implies a creation out of nothing. I was really taken, as I was doing extensive reading in this background over the last few years, is that one of the scientists has concluded, this is just a secular scientist, he says that the universe, the reality of the universe, apparently, is nothing more than a thought in the mind of God. And I thought, boy, that's right on target. I have a couple of questions to ask you before we finish up here. Would you take a course in physics if you knew they were using 1950 textbooks? Not likely. Would you take a course in physics if they're using 1970 textbooks? Not likely. Would you take... It's interesting that if you're taking a Bible study, you don't care, do you? See, the Bible hasn't changed. Physics is a constantly moving frontier. The Bible hasn't changed. You know why it hasn't changed? Doesn't need to. Doesn't need to. I want to, having gotten into all of this, I'd like to turn, if you would, to 2 Kings 6. In 2 Kings 6, we have one of these strange... There's many of these episodes in Scripture, but this one is just somehow one of the more crisp, direct ones that I enjoy. In 2 Kings 6, we have the prophet Elisha. And Syria is at it. They got war plans. Get to verse 15. The servant of the Lord, the servant of the man of God, that's Elisha's servant, the servant of the man of God was risen early, gone forth, and behold, a host compassed the city with their horses and chariots and T-72 tanks and so on. And his servant said unto him, Alas, my master, what shall we do? This guy shook. He looks out. I get the impression Elisha's on his bed, still snoozing a bit. Servant rose up and he sees they're surrounded with mighty military adversaries. Verse 16. This is Elisha talking. He answered, Fear not, for they who are with us are more than they who are with them. I sort of visualize the servant hearing that saying, Yes, but they're there. They're real. Yeah, but fear not, for those who are with us are more than they who are with them. Sounds like words of comfort. But then Elisha prayed and said, Lord, I pray thee open his eyes that he may see. And I can't help but visualize that this is sort of Elisha's impatience. He's got this young guy who's all shook up. Elisha's not worried because he knows what the score is. But I sort of visualize him saying, Lord, show him too. Come on, give him the picture. I pray thee, Lord, open his eyes that he may see. And the Lord opened his eyes, and the young man, eyes of the young man, and he saw, and behold, the mountain was full of horses and chariots of fire. around Elisha. That's one of these scenes that Cecil B. DeMille missed. Before he died, he got most of these, but I could just visualize that would lend itself well to special effects. How many of you use word processors? So it's interesting. In today's world, almost everybody uses a word processor of some kind. And as you know, when you use a word processor, there's all kinds of things going on you don't want to be bothered with. What font you're in, whether it's a hard or soft return. There's all these things that you generally don't even get bothered. You want to be able to write and see what you're writing. But every once in a while, you need to change fonts or do something subtle, or you want to double underline or whatever. You need to see the codes that lie behind the text. So there's usually a key you put called revealed codes or something equivalent that you push, and suddenly all these, in maybe another color, it's got the soft and hard returns and the change of fonts, italics, or whatever, And so you can make your corrections. But you generally don't want to see it all the time. You just want to see it at certain times. Every time I do that on my word processor, I'm reminded that that's our problem in life. We need a revealed codes key. Or we can push the key and say, "Oh, wow," So here's Elisha with his servant, panicked because he's got formidable forces around him. And Elisha tells him a basic truth: those that are with us are more than they are with them. But I can sort of visualize if that was the servant. Yeah, but there they are, Well, show them. And you suddenly realize there's a hyperspace that you and I aren't sensitive to. And I don't know if it's vibrating strings or any of that, but the point is, there's a reality that is under control of the guy that made it all in the first place. And Elisha knew he was not in any risk. Not any risk. Now it's even a little more complicated than that. Let's take a little deeper look. Turn with me to Daniel chapter 10. All through the Bible we have interesting glimpses of things like angels and Jesus coming in and out of rooms that are closed and all that. And the more you understand about modern physics, the less problems those scenes should have for you. Because you begin to realize that our physical insights, even with sophisticated equipment, are tragically limited. Especially when the astronomers tell us that what we know about the universe is limited to less than 5% of its mass. Well, not only is there a spirit world, if you want to call it that, but there's another side to it that we should also be aware of. In Daniel chapter 10, we get a glimpse of what I call the dark side. In Daniel chapter 10, Daniel goes into a prayer for 3 weeks, 21 days. At the end of those 21 days, he's visited by a messenger, an angel. And the messenger is about to give him 2 chapters of the climactic visions of the book of Daniel, chapters 11 and 12. But before he does, chapter 10 is really just an introduction to the next 2 chapters. But it's interesting that this messenger, this angel, whoever he is, I won't get into that here, points out that he was sent to Daniel when Daniel started his fast. About verse 12, he says, from the first day that you'd set your heart to understand, chasing yourself and so forth. I am come forth. But he apparently had a battle with a creature called the Prince of the Kingdom of Persia. The word prince here in this passage is used of angels, because if you notice the last verse in chapter 10, he speaks of Michael, your prince. He's talking to Daniel. Your prince is who? Michael. Who's Michael? Michael's an archangel. He's a military leader. So the word prince here, don't be confused. He's not talking about the head of the Persian Empire. He's talking about the prince of the kingdom of Persia, withstood me 21 days. But lo, Michael, one of the chief princes, came to help me, and I remained there with the kings of Persia. Now I'm come to make thee understand, verse 14, what shall befall thy people in the latter days, for the visions for many days. And he goes on to talk about it. When he gets down to verse 20, he says, knowest thou why I come unto thee? And now I will return to fight with the prince of Persia. And when I am gone forth, the prince of Greece shall come. But I will now show thee. And so he gives them. In other words, this visitor, this angel, was sent 21 days ago, but he just arrived because he was in battle with somebody who was trying to obstruct him. And he's telling you, I'm here to give you this vision. By the way, when I'm through with you, after chapter 11 and 12 is out, then I've got to go back and fight this guy some more. And after I'm through with him, the prince of Greece is going to come. The Greek Empire wasn't for 2 centuries later. So its time is somehow different. The whole environment is, we only have a misty glimpse here, but we do get the following picture. We get the picture that Daniel was benefited by a response to his prayer by a visitor who gave him a special vision. That's great. We also discover there are super forces that were hostile to Daniel and him getting this message. Here called the, whatever it means, the prince of the kingdom of Persia. And not only that, when he's through, there's another one coming. We get several insights here. This is why we believe, biblically, that there apparently is a demonic host behind each of the major world empires. The Persian Empire, the Greece Empire. That implies there may be a demonic host that's the prince of the power of the United States. Sort of see them pretty active lately. Etc. So it's spooky. And we don't see a lot of this in the Scripture, but there's plenty of background if you wanted to study diligently in Isaiah 14 and Ezekiel 28 about who the real commander is there, the God of this world, as he's called, and how he's going to surface a major leader on the earth. He has 33 titles in the Old Testament, 13 in the New. But as we read the Bible, you and I, the more you have the benefit of modern physics, the more you take the trouble to read, if you have an interest to read in modern physics, the more you know about superstrings, the more you know about quantum physics, the less concerned you need to be about the existence of angels and the spirit world. And as the Bible gives us that insight, it tells us in that world there's a warfare. And who is the prize of that warfare? You and I. We're being fought over. And the warfare is not fought with conventional weaponry. It's fought with commitments, choices, decisions. Because God has given you a frightening thing. It's called your sovereignty, your choice. And the game is to choose Him and stick with it. Because there are alien, hostile, powerful spirit forces, not visible to the instruments of quantum physics, but very visible as they move in our world, whose goal is hostile to you. Now, Einstein made an interest. One last thing. Turn again. Let's just remind ourselves as we get near the end here to look at Hebrew. I'd like to one more time look at Hebrews chapter 11. Verses 1, 2, and 3. That's where we sort of started this whole thing. Now, faith is the substance of things hoped for, the evidence of things not seen. Through faith we understand, verse 3, that the worlds were framed by what? The Word of God. So that things which were seen, things which are seen, were not made of things which do appear. Boy, that summarizes what we're talking about. Einstein made a very provocative quote back here that I'd like to return to also before we leave it. Albert Einstein, talking about these time warps and things, said, people like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion. The past, present, future is only a stubbornly persistent illusion. You know, when you and I think of eternity, we can't help but sort of think of it being out there in the future. We're here in the present. The past is a memory. The future is the hope. We live in the present, the now. I think it's very easy for us to fall in the trap of doing a misconception as far as what I call the geometry of eternity. Now give me that last slide and we'll close on this. If we view ourselves on a timeline, going from the past through the present to eternity, your connection with eternity is not in the future. Your connection with eternity is now. The eternal now. Your destiny throughout eternity will derive from your position now. Everyone in this room is in one of two categories as far as Paul's concerned, right? The preaching of the cross is to them that perish foolishness, but unto us who are saved is the power of God, right? Interesting verse, because it divides the universe in two parts. The preaching of the cross is to them that perish foolishness. I won't ask for a show of hands if any of you consider the preaching of the cross foolishness. Because if you do, you got a problem, because that Paul puts you in the first category. But unto us who are saved is the power of God. It's interesting, there isn't a third category. You're either saved or not. What determines that? Your position in Jesus Christ. You and I are the beneficiaries of a love story, written in blood on a wooden cross 2,000 years ago. And we can talk physics, we can talk concepts of reality. The real reality is Jesus Christ, who left his estate, whatever that means, and lived in our three dimensions, call it four, for a while. That alone is a staggering thing. I think I'd like to close, you can turn it off if you want, I'd like to close with one last little story. I've indulged in this series to talk about some non-biblical sources just because it adds a little. But I'd like to tell you about a dream. I got this from John Corson, and he describes this as a dream he had one night. I don't know if he really had it or just used it rhetorically, but the point is it's an interesting, I think it's illustrative. He describes a dream where the God of the universe was showing him the universe. He was moving throughout the universe, from galaxy to galaxy, enjoying the magnificence of God's creation. But as they were traveling, they started to zero in on a particular planet out here in one of these galaxies. And as they zeroed in, he was a little puzzled. Why this one? The father said, just pay attention, John. And as he got closer to this particular planet, he noticed this planet seemed to be inhabited entirely by dogs. He says, I don't understand this. He says, well, let's get a little closer. As they get closer, you realize that the planet is not only inhabited entirely by dogs, but they were nasty, vicious, snarling dogs. And he says, Father, I don't understand. The father says, well, John, that's exactly the point. You see, I know they're nasty, snarling, vicious dogs, but I love those dogs. That's the problem, John. He says, that's what I want you to do. I want you to go down there and let them know I love them. Well, you're the boss. You know, if you want to do that, you got to do it. No, John, you have to understand. In order for you to do that, you, of course, have to become one of them. You've got to become a dog. Well, you know, you're the boss. I mean, that's what you want to do, you got to do it. No, John, you have to understand. What I really want you to do, John, is I want you to become a Chihuahua. And, well, if that's what you want. One more thing you need to understand, John, is when you get down there, they're not going to accept your message. In fact, they're going to tear you to pieces. But that's okay, because I'm going to resurrect you, John. Oh, okay, that's great. But there's one thing more you should know, John, that even after I resurrect you, you will have to be a Chihuahua forever. Suddenly this little silly example takes a rather grim turn. Because you and I have this presumption that the creator of the universe, the Lord Jesus Christ, became incarnate, born in a manger, when he became of priestly age at the age of 30, ministered for 3.5 years, and then went to the cross, resurrected, you know the story. We sort of visualize him having become a man for a few years. Except in Revelation chapter 5, when John is transported thousands of years ahead, he sees in heaven, when the right hand of him who sat on the throne was a 7-sealed book, written within on the backside, and sealed with 7 seals. The word went out, who is worthy to open the book and loose the seals thereof? No man was found worthy. He had to be a kinsman of Adam. And John says, I sobbed convulsively because no man was found. And one of the elders said, weep not. Behold, the Lion of the tribe of Judah hath prevailed to open the book and loose the seals thereof. And I turned and I looked and saw the Lion of the tribe, and I saw the Lamb as it had been slain. Interesting. The only man-made things in heaven will be scars on his hands. Jesus Christ became a man so that you and I might live, and he is a man at this day. When you first study the Bible, the first amazing thing you get into is the concept that God became a man for a while. The incarnation blows you away. But then as you learn your Bible more, you begin to realize the gulf between a righteous God and a sinful man. The thing that's even more amazing that God became man, the more amazing thing, is that as you and I sit here tonight, there is a man on the throne of God. Interesting. He's a man forever. Now, the reason I use a silly little story is the step down you and I would take to become a Chihuahua is less of a step down than the Lord Jesus Christ took in becoming a man, so you and I might live. And he's a man today. Admittedly, in a resurrection body, fine. But he's a man today. Why? Because he loves you and I, so you and I can live. So as we study our Bible and as we get confronted with newspaper accounts of neutrinos being discovered and this particle world and the stumbling gropings of science, we can just smile because it's all here, written by the guy who did it in the first place. And as they discover superstrings, and they discover that in fact all these things are a vibration of a higher dimension, and as they discover there isn't substance there, it's all a thought in the mind of God. Praise God. He said so all along. Let's stand for a closing word of prayer.
For a complete listing of materials to further enhance your personal Bible study, or to be added to our mailing list, contact Koinonia House at area code 208-773-8524. To fax your correspondence, dial 208-773-8324. Or you can write to Koinonia House, Post Office Box D, Coeur d'Alene, Idaho, 83816-0347.